radiation technology is a technology that uses infrared waves, which are a type of electromagnetic radiation invisible to the human eye. Infrared radiation is produced by all objects that generate heat and is commonly used in many modern devices and systems. This technology plays an important role in communications, medical applications, security systems, and industrial processes. Today, infrared technology is widely used because it provides fast, wireless, and efficient operation in daily life. Devices such as remote control, thermal cameras, motion sensors, and infrared thermometers rely on infrared radiation to function effectively. The advancement of infrared technology has improved convenience, safety, and automation in various fields. For the explanation, infrared radiation technology works by using infrared waves to detect heat and transfer signals between devices. Infrared waves are part of the electromagnetic spectrum and have longer wavelengths than visible light. Although humans cannot see infrared radiation, it can be detected as heat. This technology operates through two main components. First is infrared transmitter and the second is infrared receiver. The transmitter sends infrared signals while the receiver detects and interprets the signals. Infrared signals can travel through the air without wires, making communications faster and more convenient for short distances. Infrared radiation is commonly produced by warm objects such as the human body, electronic devices, and the sun. Sensors can detect this heat emission and convert them into electrical signals for different applications.
Hi, my name is WARDAH, and today I'll be presenting about a detailed exploration of thermography. First is capturing the black body radiation. Every object with a temperature above zero emits thermal infrared energy, which is the black body radiation. Thermography maps this invisible energy. The second one, the microbolometer array. Thermography instrument don't use regular camera sensors. They use specialized chips called microbolometers, which physically changes electrical resistance when struck by infrared heat waves. The third one is creating a thermogram. The microbolometer detects tiny temperature differences, and the internal computer translates these heat intensities into a color-coded visual map called thermogram, where bright yellow or red color indicates heat and blue or purple indicates cold. For the next one, it is real-world implementations. First is industrial predictive maintenance. Electrical engineers use handheld thermography to audit electrical grids and factory machinery. It instantly exposes the overheating wires hidden behind paneling before they cause danger. Second one is medical diagnostic support. In healthcare, clinical thermography acts as non-contact tool to map skin temperature, help doctors identify blood circulation disorders, and localize tissue inflammation. And the third one is renewable energy grid auditing. Technicians use thermal cameras, often mounted on an aerial drone, to rapidly screen a solar power plant. This allows them to spot overheated hotspots that are invisible to the naked eye.
Now, I will discuss the benefits of infrared radiation technology. The first benefit is non-contact temperature measurement. Infrared devices can measure the temperature of an object or person without direct contact. This is this is especially useful in healthcare, where infrared thermometers can reduce the risk of spreading infections. In industry, they can safely monitor the temperature of hot machinery and equipment. The second benefit is night vision and thermal imaging. Infrared technology detects heat emitted by objects, allowing visibility even in darkness or poor weather conditions. This technology is widely used in security systems, military operations, and search and rescue missions to locate people and objects. Another important benefit is energy efficiency. Infrared heating systems transfer heat directly to objects and people instead of heating the surrounding air. As a result, less energy is wasted, making infrared technology is more efficient and environmentally friendly option. Overall, infrared technology improves safety, efficiency, and convenience across many fields. Despite its many advantages, infrared radiation technology also faces several challenges. The first challenge is limited penetration. Infrared radiation cannot pass through most solid objects and walls, which limits its effectiveness in certain applications. The second challenge is the high cost of equipment. Advanced infrared devices, such as thermal imaging cameras, can be expensive to purchase and maintain, making them less accessible for some organizations. Another challenge is environmental interference. Factors such as dust, smoke, fog, and humidity can affect infrared signals and reduce the accuracy of measurements and imaging. Finally, there are privacy concerns. Since thermal imaging can detect heat signatures from a distance, some people may feel uncomfortable about its use in surveillance and monitoring activities. In conclusion, while infrared technology offers many valuable benefits, these challenges must be addressed to ensure its effectiveness and responsible use.
Now let's talk about the future developments and innovations. So as we know, our world is going to be much more tech savvy in the future, perhaps 40 or 50 years into the future. So including our medical equipment is going to have much improvements. So for example, improvement in thermal imaging cameras. We're going to have a much more accurate, affordable, and accessible technology for our daily uses. And then integration of AI. Even now, our world is going into a much more AI situation, which we use AI in our daily life. So is this a good thing? Absolutely. AI helps us in medical diagnosis by, capturing into things that we sometimes look past. Like, for example, abnormal body temperatures, and helped us detect certain sickness or, some health problems at an early stage. And then we're talking about the transportation. So autonomous vehicles, they're going to have a further development, helping the sensors, for example, help detect the pedestrians, animals, objects, or any obstacles. And by having those things, it helps to secure the security of the autonomous vehicles itself. And it will also improve by, helping us detect them even in the dark or the bad poor weather conditions. And then our favorite part, the communication. So every day we are hoping for a faster and a secure data transmission. By having some improvement in the infrared radiation technology, we are providing it. And then, a much more massive use in technology in the, smart homes, security systems, and overall energy saving technologies. So as the infrared radiation is expected to follow all of those rules, having a much more safer, smarter, and more energy efficient solution in the daily life as the technology continues to evolve. In conclusion, infrared radiation is a type of electromagnetic radiation that has many applications in our daily life. So it is widely used in thermal imaging, medical treatments, remote control, security systems, and overall industrial processes. So the continuous development of the technology has improved its effectiveness and expanded its range of application. And with future innovations such as AI, a much more secure security system, advanced thermal imaging, infrared radiation technology will continue to bring great benefits to more improvement in the community. All in all, infrared radiation remains as an important technology that helps improve safety, efficiency, healthcare, and overall uses of quality life.